Assalamu alaikum. Welcome back with a paper October number 2022. This is a mechanics paper having a code 43. So the first question that we have to work for, a particle P is projected vertically upward with a speed u meters per second from a point on the ground. P reaches its maximum height after 3 seconds and you have to find this velocity. If you consider a diagram, then it is easy for you to understand. The scenario is that initially the particle is lying on the ground, right? So after 3 seconds it is moving in upward direction. So the time that is given to you is 3 seconds. And initially the velocity of this body is unknown. You have to find its time velocity at which this is going to start its velocity, its motion actually. So for some time when the body attain its maximum height for approximately 0.00009 second, the body will comes to rest. When it comes to rest, then its velocity will be treated as 0. So it means that its final velocity in this case will be 0. And after that it going to start in downward direction. For this scenario, when time is 3 seconds and the body is moving in upward direction, it have the acceleration due to gravity but in opposite direction because it is moving in this direction, right, opposite to gravitational acceleration. So it would be minus 10 over here. I know one of a famous equation of motion. You can say the first equation of motion, that is v is equals to u plus at. V is 0 over here, you have to find, a is minus 10 and t is 3. So just do the calculation and subject your equation as u, that gives you 30 meters per second. That is the answer for this A part. For the B part, you have to find the greatest height of a particle P above the ground. So in order to find the height, if you again consider the scenario, this is a particle, this is moving in upward direction, the time is given to you, that is 3 seconds. That height you have to find. That much height the body is going to cover. Again consider the second equation of motion, or a third one you can say, that is s is equals to ut plus half of at square. For example, this is equation number 1 for that. Look at the things that are given to you already. U is given to you, t is given to you, acceleration due to gravity is also known, time is again known. So I can use this equation clearly because I know the relevant values over here. So s will be acting as h over here, and u is known by the first part, that was 30, time was 3, half of a is again minus 10 because it is moving in this direction, that would be opposite to gravity, so minus 10. T is the time, that would be 3 square. So h will be 30 times 3 is 90 minus 5 times 9, that is 45. So 90 minus 45, that gives you h, that is 45 meters, because distance is always measured in meters. So that's why its value will be coming as 45 and unit would be meters. That's all about that. Second question is, a box of mass 5 kg is pulled at a constant speed of 1.8 meters per second for a time 15 seconds on a rough surface that is inclined at an angle of 20 degrees from the horizontal. The box move along a line greatest slope against a frictionless force, and that is for 40 Newton in magnitude. You have to find the change in gravitational potential energy. So your first step should be writing the formula for gravitational potential energy. GPE, which is equals to mgh. You know that mass is, m is mass, g is gravity, force due to gravity, and h is the height. So it is useful for you to draw the figure, then it is easy to understand. This is, for example, my body that is lying over here, and the angle between the horizontal surface is acting as 20 degree. That is the height that I have to find. So trigonometric ratios can be used over here, that can be written as perpendicular by hypotenuse, but I don't know the value of this hypotenuse. that is actually the distance. So my first step should be finding this distance. For example, this is my equation number 1. So distance would be s is equals to v times t. I know the value of v, that is 1.8 over here. Also I know t, that is 15 seconds. So s is equals to 1.8 times by 15, that gives me 27 meters. So this 27 meter is basically my value for this distance. That one. Then I have to plug this value in this trigonometric ratios, because now I know the value of each. So I know the value of each. It can be written as each sine of 20 degrees. Why? Because this is inclined at an angle of 20 degree, and it is along a vertical component, so that's why it will be sine, and because of inclined in nature, that would be 20. So plug the relevant values over here in this main equation number 1. That gives you mass is 5 times by gravity, and that is again 10, and it is along the direction of it's moving downward, so its direction is along the gravitational acceleration, so no need to consider minus, that would be positive, times by each is sine of 20 degrees. So each is basically 27 over here, so it is 27 sine of 20 degrees. So 27 sine of 20 degrees. Just hold on your calculator and do the simplification. Then your S would be coming as 461.7, because this is height and height is again in meters. So that answer would also be in meters. For the next one, you have to find the work. Look at the formula for work done. Work done can be written as F dot D. So D is known to you, that is calculated by the A part, and it was 27 meters. The thing that you have to work for is F. So you have to work for F first, then use this formula. So F will be calculated if you consider again the same figure like that. This is 20 degrees. Here is the body that is lying, and it is the weight of this body, that is equals to m times g. Mass is given to you in this statement, that is 5 kgs, and g is 10, so its w will be 5 times 10, that is 50. Now resolve this weight into its component along a horizontal component and a vertical component. So this weight can be resolved into two components, 50 sine of 20 degrees, and vertical component would be, this is vertical, and horizontal component would be that one, that is 50 cos of 20 degrees, right? Other than the force that is acting on this block is, from the statement, it's 40 Newton frictional force. So 40 Newton frictional force plus 50 Newton, that body force, overall the opposite force that is acting over here is 90 Newton. So I can calculate this F by using Newton's second law of motion, and it is summation of F is equals to ma, and F can be written as forward force minus reactional force, that is 90, oh sorry, that is 40 actually, 40 minus 50 sine of 20 degrees, which is equals to mass time acceleration. Its mass is 5 kgs, but its acceleration is 0, because the change in velocity is 0. So 5 times 0 is die out, and its right hand side will become 0 again. So your F will be 40 plus 50 sine of 20 degrees. So hold on your calculator and do simplification. Your answer will be somehow 40 plus 50 sine of 20 degrees. Then again put this f in this main equation that is marked as equation number, for example, 2. So w is equals to 40 plus 50 sine of 20 degrees times by d is what? D was 27 meters. So do the simplification, then your work done will be 1541.7 joule, because work done is always measured in terms of joule, so that's why it will be in joule. That will be your final answer for that. Okay, next is question number 3. It's tricky. A ring of mass 4 kg is thread on a smooth circular rigid with a center C. The wire is fixed in a vertical plane and ring is kept at rest, the light string connected to A, the highest point of this circle, and making an angle of 20 degree to the vertical axis. Find the tension in the string and the magnitude of the normal reaction of the wire in the ring. Okay, so you have to find tension. So first of all, complete the figure. This is in this way and this is in this way. So you can say this is a vertical component because it's an angle of 20 degrees, so it would be h of cos of 25 degrees, and it would be h of sine of 25 degrees, right? So normal reaction would be in this way, and this is the weight that is acting in downward direction. Resolve this normal reaction into its two component. This would be its horizontal component and its angle would be 50, like cos of 4 times cos of 50, and it's another normal vertical components would be 4 sine of 50 degree. Now the question arises, how you can say that it should be 50? That can be figured out by using a right triangle formula. From this figure you can see one of the angle is 25, the other one angle is 90, and sum of angles in a triangle is 180. So by using this concept you can find the remaining angle, this one. And again you have this type of triangle that is marked over here, this one, this one, and this one. So after doing that, that angle will be coming as 50 again, and alternating angles are always equal, so 50 to the 50 opposite angles are equal, so that angle should also be 50 over here. Basic trigonometric rules are applicable, not an issue. So after writing or completing the figure, you can find the tension by considering the vertical component first. So vertical component, it would be t cos of 25 degrees, which is equals to 40 plus r cos of 50 degrees. R is basically a reactional force that is acting normal to it, just like that. So t cos of 20 degrees is equals to 40 r cos of 50 degrees. I have to find this t, so subject your equation as t, that gives you 40 over t cos of 25 degrees plus r cos of 50 degrees to the, basically this t will not be there because I have to subject my equation as t, so that would be cos of 25 degrees. Do the simplification, then your t would be coming as 44.135 plus 0.7092 r. Now the problem, this r is creating a problem, this one. I have to find this value of this r, so that r will be figured by using a horizontal component. So consider the horizontal component. Horizontal components, that can be written as r sine of 50 degrees, which is equals to t sine of 25 degrees, right? So subject your equation as r. I'm not doing whole of the simplification because space is very low. Here you have to just plug the relevant value of t over here and do salute, and further your r will be coming as 18.65 over 0.466. I'm not going to do that step because I have less space and I have to find the answer completely. There is another question below it, so that's why I'm just writing directly. You can do direct simplification, just only calculation, nothing else. So after that your r will be 40 newtons. Now you know the value of r. This is my equation number 3. So at this place of r you have to plug its value over here. That gives you t is equals to 44.135 plus 0.7092 times by 40. So do the multiplication and addition, and at the end your value for this t would be 72.5 newton. So that will be the answer for question number 3. Next is question number 4. Question number 4 suggests that the particle p travel in a position positive direction along a straight line with constant acceleration. P travels a distance 52 meters and second its motion, it's having a distance of 64 meters during the fourth second of its motion. Find the initial speed and the acceleration of this P. Okay, so this whole of this scenario is divided into two parts. First one is at the second means for the second part of time, and the other one is fourth second of time. So I will calculate the distance for the first scenario and distance from the second scenario. This is first scenario and this is second scenario. So after doing calculation, I will subtract both of them to find my acceleration, and then integrating the acceleration, I am able to get my velocity, right? So let's start. Distance for second of time, right? So it would be s2 minus s1, that is equals to, I can consider the equation of motion, that is ut plus half of at square. So u times t is because second, so 2 seconds plus half of a is unknown, and again t would be 2, minus s1 is u of 1, this is inside, plus half of a1 square, because I'm working s1 means its time is acting as 1 second. So let's do the simplification. That gives me 2u plus 2a minus u of minus a by 2. After that, that give me u plus 3 by 2 of a, because this one is u and 2a minus a by 2 is 3 by 2. So this is my distance, that is coming as 52 meters for that. So that's answer for my first scenario. Let's start for the second one. For fourth second, that would be s4 minus s3, and that gives me, again using the same equation of motion, ut plus half of at square, that gives me u of 4 plus half of a 4 square minus u of 3 plus half of a3 square, hold on brackets, that is equals to 64 meters, because for that scenario the distance covered is 64 meters over here. Okay, so after doing simplification, that gives me 64 is equals to, I'm doing it directly, u plus 7 by 2 times of a. This is the answer for second scenario. Now I have to subtract equation number 2 minus equation number 1. So that gives me 64 minus 52, which is equals to u plus 7 by 2 times a minus, the equation one was u plus 3 by 2 times a. So do it and your answer will be coming as 12 is equals to 2 times of a. So 12 is equals to 2 times of a, and a would be coming as 6 over here. Now I know the value of this a, right? So I know the value of a by any equation. By considering either equation number 1 or 2, I can plug the relevant value of a to calculate my answer for this u. So I'm considering the first one. Equation number 1 implies 52 is equals to u plus 3 by 2 times of this one a. So it would be 3 by 2 times of 6, and subject my equation as u. That gives you 2 times 3 is 6, 3 and 3 are 9, and 52 minus 9 would be 43. So u would be 43 meters per second. That is the answer for that. Find the distance traveled by p during the first 10 seconds of its motion. Now there is a restriction over time, like you have to fix the time is equals to 10. So s of 10 would be written as u times t plus half of at square. T is fixed, so I have to, at the place of t I have to put down 10, right? So u is known by the first part, that was 43, so plug its value. 43 times by 10 plus half of 6 times 10 square, because a is calculated in this upper part, that was 6. So doing the simplification, 430 plus 300, that gives you 730 meters. That is the answer for that. Okay, next one is question number 5. Particle x and y moving along a straight line and the points of a and b. Particle x start from a rest and move towards b. Similarly, b starts from a rest and move towards a. For some time instant, the particles or acceleration for AB is given to you in this one, in this first equation, and from the particle or the acceleration of this y is given in the second equation. You have to calculate the distance of AB. In order to calculate the distance of AB, the thing that is given to you, that it is given that the velocities are equal. So first of all, you must have to consider this thing over here, that their velocities are equal. When their velocities are equal, then definitely their accelerations will be equal, right? So let's start. Because their velocities of x and y are equal, it means that vx is equals to v of y. So vx is equals to v of y. In order to get velocities, these are the acceleration in expression number 1 and expression number 2. So I have to integrate its acceleration in order to get velocities, right? So it would be written over here, integration of the first expression, that is 12t plus 12 dt, which is equals to second expression, that is for y, 24t minus 8 dt. So apply the power rule of integration. That gives you 12t square by 2 plus 12t, which is equals to 24t square by 2 minus 8t. So do the simplification. 2 times 6 is 12, so it would be 6t square plus 12t minus 2 times 12 is 24. So shift this 12t square on the other side, that will be minus 12t square, and 8t onto the other side, that will be positive 8t, which is equals to 0. Now solve this quadratic equation, similar terms together, this one and this one. So by doing this one, you have 6 plus 6t square minus 12t square, that again gives you 6t square minus 6t square, actually 12t plus 8t, that gives you 20t, which is equals to 0. So 6t square plus 20t, which is equals to 0. You can take minus outside, and that further gives you 6t square minus 20t, which is equals to 0. You can also take 2t common. So 2t taken common, that gives you 3t minus 10t. T is common, no, just only 10, which is equals to 0. Now here two cases arise. First one is 2t is equals to 0, and other one is 3t minus 10 is equals to 0, that is 3t is equals to 10. So that gives you t is equals to 0, and that gives you t is equals to 10 by 3. Now you have the range over t, 0 to 10 by 3. These are the ranges for this t. Now you can integrate this expression either for x or y by considering the range, that is 0 and 10 by 3. So you know the expression 6t square plus 12t, that is for this one. Let me highlight this one. This is for this x position. Now you have to do it by just only apply the limit over here. So apply the limits, that is basically, let me write it down first. 2t square, oh sorry, cube plus 6t square. I'm talking about x. This is for x particle. Its range is 0 to 10 by 3. So just plug its values over here. When you did plug, it gives you 2 times 10 by 3 whole cube plus 6 times 10 by 3 whole cube, square actually, minus 0, that will be die out. So solve this one, and your answer will be coming as 3800 dividing by 27. This is for particle x, so that's why I just marked as sx. Same thing I will do for sy, that is highlight with this blue marker, this one. This one. So doing this one, what give me sy. So sy is equals to 4t cube minus 4t square, and the range over it is 0 to 10 by 3. So that gives me 4 times by 10 by 3 cube minus 4 times by 10 by 3 square, minus 0 will die out, and further its answer will give me 2800 dividing by 27. That is the answer for sy. Now I know two answer. First one is sx and the other one is sy. This one, it's creating a problem to highlight. That's why I'm not using, that's why this one I'm always using notepad, because that is creating a lot of problem while doing highlighting. And for the next time I will use again OneNote. So in order to find the distance AB, what you have to do, you know that this is a point A and this is a point B. A is moving toward this, B is moving toward it. So Sx would be positive, but Sy would be negative because its direction is in opposite. So the total AB would be Sx minus Sy. So plug its values over here, and that gives you 3800 dividing by 27 minus 2800 dividing by 27. Taking the LCM and doing simplification, that gives you 1000 dividing by 27, and further that gives you 1000 by 27 is 37 meters. So the distance of AB, you can say SAB, is 37 meters. That's all about that. For the next one, it is given that instead the AB is 36. Verify that X and Y collide after 3 seconds. So you have to use the time 3 seconds, and you have to show that the distance should be 36 instead of 37. So let's try. AB is basically what? Sx minus Sy. So plug its relevant expressions that you have calculated in this first part. That was 2t cube plus 6t square minus 4t cube plus 4t square. That was the expression that are calculated here while doing the integration, this one. So solve it. That gives you minus 2t cube plus 10t square. Now you have to put s is equals to 3 over here in order to find distance. So when you put s is equals to 3 over here, t, you can say t is equals to 3 over here, that gives you minus 2 times 3 cube plus 10 times 3 square, and your answer would be 36 meters. So it's proof that whenever you choose time is 3 seconds, then your answer would be, for distance it should be 36 meters. So that's all about question number 5.